we are going to start with some definitions. The first definition that we're going to review is what it means for an angle to be in standard position. And in order for you to get a good sense of what this is, I'm going to start off by drawing a bunch of angles in standard position and a bunch of angles that are not in standard position, because I find that the visual will really help you understand the definition. So you don't have to draw these down. I'm going to split my page. I'm going to put this side as yes, this side as no, and I'm going to draw a bunch of angles in standard position for you. So for example, here's one, here's another one, here's an angle in standard position, there's an angle in standard position, and there's an angle in standard position. And then I'm going to draw you some examples of ones that are not. So So the first 5 under the yes category are all angles in standard position, and the other ones are not. So what we have to do is we have to look at, can we tell a pattern in the ones that are in standard position, something that they all have in common, and make sure that that doesn't ever happen in the ones that are not. So the definition is, and see if this makes sense to you, an angle is in standard position if it starts at the positive x-axis. That's the definition of an angle in standard position. Now what I'm going to do is in green, I'm going to look at where does each angle start. So can you see this one starts there, 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 this one started here, this one started there, this one started there, and this one started here. So the green line is where the angle started. We can tell where an angle starts compared to where it ends. The arrowhead points to where it ends. Where you don't have an arrowhead is where the angle starts. So each of the ones in standard position always will start at the positive x-axis. It's okay if it goes around more than once. It's okay if some of them started counterclockwise and some of them started clockwise. We're going to find out later that this angle is positive. Well, we're going to find out right now, I guess. And this angle is negative. That if you go clockwise, you'll have a negative angle. If you go counterclockwise, you'll have a positive angle. So this is definition number 1 from grade 11, a review of what does it mean for an angle to be in standard position. Definition number 2. Also from grade 11, what is a reference angle? Again, I'll do a visual, some that are yes, some that are no. You don't have to draw these down, but they're just to help you see things. again, we take a look at the pictures, see if we can see what's in common in the ones that are yes, make sure that that doesn't come up in the ones that are no, and we can write out the definition. So the definition of a reference angle is the acute angle, less than 90 degrees, between the terminal arm and the nearest x-axis. So I'm going to draw all of my terminal arms of the angles in purple. And the terminal arm is where an angle would end. These are all the terminal arms. The nearest x-axis is there in green. Notice that here's my nearest x-axis, but I didn't label the angle between the terminal arm and the nearest x-axis. Here's my nearest x-axis. I didn't label the angle between that and my nearest x-axis. Here's my nearest x-axis. This one is between, right? It started on the nearest x-axis and ended at the terminal arm, but it's not less than 90 degrees. It was the actual angle that went past 360 degrees for that last one. So our reference angle is always the angle between the terminal arm and the nearest x-axis. Also a definition from grade 11 that we did. And now here is a new definition for us for grade 12. Coterminal angles angles that share the same terminal arm are coterminal angles. So that would be, for example, if I drew 20 degrees here, can you see that if I went all the way around and ended in the exact same spot, that angle would be 380 degrees. So 20 degrees and 380 degrees are called coterminal angles because they end at the same spot. So we're ready to go to example 1. In 1A, we want to draw a sketch of this. We're starting with 85 degrees, so 85 degrees in standard position would look like that. And we want to determine the measure of all the angles in standard position between -800 and 800 that end in the same place as 85 degrees. So I want to find out what is coterminal with 85 degrees. Well, obviously, you could write 85 degrees. 85 degrees ends in the same place as 85 degrees. But I could also go all the way around and end in the same spot if I wanted to figure out what that would be. Does it make sense that I could go and just add 360 to the 85 degrees that I had, right? If I'm pointed in one direction and I jump and spin 360 degrees, I'm going to land and be pointed at the same direction. Okay. Bad example because I don't think I could actually give you a very good visual of that. If I tried to jump up and spin perfectly 360 degrees, I might twist my knee, fall down, could be disastrous. Might be very entertaining, but probably disastrous. So we can find this green angle by adding 360, and we would get 445 degrees. We could find another one if we added 360 again. If I add 360 again, I'm going to get at 805 degrees. So that's a possibility of being coterminal, but they say, no, stop at 800. So we don't have to write 805 degrees. But I could also find coterminal if instead of adding 360, I could spin the other way, and I could subtract 360 degrees. So if I went around this way, that would be 85. I go to my calculator, do 85 minus 360, negative 275 degrees. That would also be coterminal with 85 degrees. And if I subtracted 360 again, this graph is getting very full. If I subtract 360 again, I would get negative 635 degrees. And our diagram has a bunch of spinning circles. So many spinning circles that, unbeknownst to you, I just hypnotized you. You didn't even notice. You guys are all right now in a hypnotic state, and you didn't even notice. It's like sneaky of me. I do this so that I can like influence you in a positive way. Like from now on, like when you wake up from this hypnotic state, you will not remember this at all. But you will also really like math and be like encouraged to be like, oh, this weekend I'm going to get my take-home quizzes done, and it's going to be fun, and I'm going to enjoy it, and I'm going to be like thinking about it and understanding it. All of that will happen. So when I snap my fingers, you will come out. You will have no recollection of this whatsoever, but you'll find moving forward, you're like, oh, I like math. I feel like doing my math homework more often. Awesome math. Part B. Write an expression for the measures of all the angles that are coterminal with 85 degrees. So we found 4 of them. And you can always find another one by adding another 360. Then adding another 360. This kind of sounds like a very mean question. That if you started to write them all down, and you didn't stop, you will be writing for the rest of your life, and you will die and you will not finish before you will die, because there's an infinite amount of them. Now, mathematicians sometimes want to write all the answers down, but we run into this problem, because if there's an infinite amount of them, this is going to take forever. So we come up with a system to write this down. The way that we write an infinite amount of answers down is with a pattern. We say, you can find any of them by starting with 850 degrees. And then you can add or subtract 360 degrees as many times as you want. So we write it like this. Times by k, where k belongs to the integers. And a review of what are integers, those are our positive and negative whole numbers. So by writing it this way, it says you can add 360 2 times if you make k2. You can add it 1 time if you make k1. You can add it 0 times and stay with 85. Or you could subtract it twice if you make k negative 2. And if we write it this way, where k can be any whole number, positive or negative, anywhere, any integer, we've written them all down. We basically made a formula saying this is how you could find any one you wanted. If k was 752, you could take 360, times it by 752, add it to 85, and you would find a new angle coterminal with 85. All right, I'd like you to circle questions 4 and 5.